Here is the next example. Here he's asking about find Ix in that given circuit. Now here we have only one source, but all these resistors, they are not in series or parallel combination. This combination is called star and delta. We can solve it by using star and delta method, but physics students don't know yet what is star delta, but circuit students can able to solve this by using star delta method. So for physics students as well as circuit students too, we can solve this by using KVL and KCL. So I'm going to find Ix value by applying KVL and KCL. So step 1, what I'm going to do, I'm going to assume I current is starting from here, I is coming there. I'm assuming I current is splitting I1 and I2. Okay, so I can clearly see total I equal to I1 plus I2. That's one equation. Okay, now this I1 current comes there. It's going to split again. Let me take this as I3 and I4. How do I know whether this I3 is going down or going up? It could be going up. I don't know at this point, but I'm just assuming I1 is splitting into I3 and I4. So my next equation, I1 equal to I3 plus I4. This is my second equation. Now this I2 and I3 are going to come over here. Okay, and I4 is coming from there. Now my I equal to I2 plus I3 plus I4. Okay, so I3 plus I4 is nothing but I1, these two together. Okay, so I1 plus I2, I equal to. Now according to, based on your current direction, as I told you, when you're applying KVL and KCL, you have to assign, especially when you're applying KVL, we have to assign the positive and negative sign. Okay, so here my I1 is entering here, so this is positive negative. I3 is entering there, positive negative. I2 is entering positive negative. I2 plus I3 is entering positive negative. My goal in this whole thing is finding Ix. Can I say my Ix is same as I3? So my goal is now finding I3 value. Okay, I have only 2 equations, but how many unknowns? Almost 5 unknowns. So I need at least 3 more equations. Now I'm going to define one equation, apply KVL in any loop. Okay, so to get all the remaining 3, apply KVL in a loop. Loop is nothing but your starting point and ending point is same. Okay, so and sum of the voltage drops and voltage gains must be equal to 0, or another way of saying it is voltage drop must be equal to voltage gain. So I'm going to start walking from here. Okay, I'm going to go this path and then go through 14 ohm and come back here and then reach there. That's the loop. Okay, I'm going to label this as loop 1. Okay, so loop 1, I'm going to say apply KVL in loop 1. So here, is this voltage drop or gain? I'm entering the positive terminal, so that must be voltage drop. How much voltage is that? That must be 25 times I2. Is this voltage drop or gain? That's voltage drop since I'm entering the positive terminal. How much is that? Plus 14 times I2 plus I3. Okay, is this voltage drop or gain? Here I'm entering the negative terminal. Okay, remember for the battery, this short one is always negative terminal. So that must be voltage gain equal to 6. This is my third equation. Let me simplify this. 25 plus 14, which is 39 I2 plus 14 I3 equal to 6. This is my third equation. Now, as I mentioned, I have 5 unknowns. What are those? I1, I2, I3, I4 and I. So I need 5 equations. So far I have only 3. Another one I'm going to follow. In the same way, can I follow, or I can start, let me start from here. I'm going to follow the upper path instead of the lower path. Okay, so I'm going to follow this direction. So apply KVL here. Okay, I'm going to write down right there. Is this a voltage drop or gain? That's a voltage drop. 22 I1. Okay, here current is entering, so I forgot to put this plus or minus, so that's a voltage drop, plus 12 I4. Okay, equal to, so from there I'm going to come back here, equal to 6. This is my fourth equation. Okay, let me copy it here. The fourth equation is 22 I1 plus 12 I4 equal to 6. This is my fourth equation. Now I have 4 unknowns. I need one more equation. It's up to you. You can follow any path. Now I'm going to follow this path. Okay, let me call this as loop 2. Okay, apply KVL in loop 2. Apply KVL in loop 2. Okay, so here this is voltage drop, which is 22 times I1, voltage drop, which is 15 times I3. Here I'm entering negative terminal, so that must be voltage gain. So 22 times I1 plus 15 I3, those two are the voltage drops, and 25 times I2 is the voltage gain. Since I'm entering the negative terminal, so 22 times I1 plus 15 times I3 equal to 25 times I2. This is my fifth equation. So I have 5 unknowns, 5 equations. I can easily solve for Ix. Okay, there must be another way of solving this. Okay, that's called mesh analysis. So here I have 5 unknowns, 5 equations. Solving 5 unknowns, 5 equations is little difficult. If I solve it by using mesh analysis, I can go with only 3 loop equations. Okay, so mesh analysis, as I mentioned, I have a whole bunch of examples I solved in the next chapter. Please go through the mesh analysis. I didn't find Ix here, but I have 5 unknowns, 5 equations. I'm going to leave this example here. Solve those 5 equations. You can and solve for I3. Once you find I3, your I3 is nothing but Ix. For circuit students, we can solve this another way, as I mentioned. Most probably I'm going to solve it later on in the same chapter. We're going to solve it by using either star or delta method. Okay, I will talk about star and delta method in future videos. I'm going to solve at least a couple of more examples by using KVL and KCL in the next video. Thank you.